All right, so let's do a brief review over 6.2. And it was about parallelograms, wasn't it? Isn't that the title of the lesson? Yep. So what in the world is a parallelogram? Well, I just happen to have a parallelogram sitting right here. It just happened to. And let's see. So if this is a parallelogram, by definition, I'm going to write a lot of stuff on this parallelogram. Might be a good idea to even put this in your notes right now. Even though I did teach it last Wednesday when I was gone through the video, it still might be a good idea to write some of this down. Okay, by definition, it's a parallelogram because both pairs of opposite sides are parallel to each other. Hear what I just said? Both pairs of opposite sides. So this is one pair of opposite sides, so by definition, it has to be parallel. Is that the only thing that's true about it? No, what did I say? Not just one pair, but what? Both pairs of opposite sides have to be parallel. So this side right here has to be parallel to this side over here. That's by definition. Okay, the definition of parallelogram says it's a quadrilateral. What does it mean to be a quadrilateral? Somebody tell me. Nah, not to be a quadrilateral. Give somebody else. Somebody tell me what a quadrilateral is. Danielle, tell me what a quadrilateral is. Quad meaning what? Okay, so if it's a quadrilateral, what does that mean? Four-sided figure, that's right. Okay, it's four sides, okay? So this is four sides, isn't it? But this is more specific than just any four-sided figure. This is a four-sided figure, a quadrilateral, that has both pairs of opposite sides parallel to each other. That means it's a parallelogram. Now, there's a lot of stuff that we know about this if it's a parallelogram. So let's go through some of those. All right, so the first thing I think we talked about is if this is a parallelogram, then the opposite sides are not just parallel to each other, but they're also what? They're equal to each other. Do you see that? A little tick mark means they're equal to each other. And both pairs of sides are equal to each other. So these two are equal, and guess what? This one and this one right here are also equal to each other. All right? It's a theorem or postulate or something. I forget exactly. But there's something that tells us that both pairs of opposite sides are equal to each other. We good with that? All right. We also knew something about the angles. Do you remember this? Look at this angle right here and this angle right here. What do you think might be true about those angles? Take a wild guess. Yeah, they're equal to each other, okay? Because we have a theorem that says that the opposite angles of a parallelogram are also equal to each other, okay? So if this is a parallelogram, which we said it was, right, because both pairs of opposite sides are parallel, then that means the opposite angles are equal to each other. I'll tell you what, let's label this so we can talk about the angles and sides. All right, so angle A must equal angle C if it's a parallelogram. Now, I said both pairs of opposite sides. I think I did. I meant to anyway. Both pairs of opposite sides are parallel. So A and C are equal. Well, what else might be equal to each other? B and D must be equal to each other, right? So B and D must be equal to each other as well. All right, so we know that about a parallelogram. Remember, this is not true about any four-sided figure. This is only true if it's a what? Parallelogram. Let's write that word down. Okay, parallel. How do you spell parallel? P-A-R-A what? Two L's, then one L. Okay, that's parallel. Everybody got that? And then ogram, right? O-gram. Parallelogram. There it is. It's not too hard to spell, is it? If you know how to spell parallel, you should be able to spell parallelogram. So if this is a parallelogram, all this stuff's true. The opposite sides are parallel, the opposite sides are equal, and the opposite angles are equal. But there was other stuff that we knew about this. What about like A and D? What do you think might be true about A and D? They're supplementary. Very good. They're supplementary to each other. Which means what? Cookie, what does it mean to be supplementary to each other? It means these two angles do what? They add up to 180, right? Okay, they add up to 180 degrees. So A and D add up to 180. What do you think might be true about A and B? Justin, what do you think? What might be true about A and B? They add up to 180 as well. So give me a good geometry word. Then they're what? Then they're supplementary, right? A and B are supplementary. All right. Madison, tell me something about B and C. What might be true about B and C? They add up to 180 as well. See, everyone with a 1 arc and a 2 arc add up to 180. Now, why? We might have gone through this last Wednesday, but why is angle A and angle D supplementary? Because you got parallel lines cut by transversal. Do you remember all that? Okay, way back in another chapter. Two parallel lines cut by transversal. These are consecutive interior angles. Any of that ringing a bell? Okay, consecutive interior angles are supplementary. That's the reason why. So A and D are supplementary. A and B are supplementary. We said B and C are supplementary. I got two other ones. What else is supplementary? Anybody tell me? D and C. Right. D and C are supplementary. Everybody got that? So they add up to 180. So if I told you that this was 80 degrees, this angle D right here, what would angle C be equal to? Be 100 degrees, wouldn't it? All right, and of course A would be the same thing as C, so that's got to be 100 degrees. Agreed? And then if this is 80, what's B? That's got to be 80 as well. Make sense? All right, but this is only true if the figure is a what? Parallelogram, right? Okay, only if it's a parallelogram, all that stuff's true. Now we had something else in here, didn't we? What did we draw? We drew some lines. Do you remember what we called those lines? Diagonals. Very good. So if I drew a line here, connected those corners, and a line here that connected those corners, we call those two lines diagonals. Now, we knew something about the diagonals, or the lengths of the diagonals. Let's do this in red. Anybody remember what happens with the diagonals? They intersect each other, but they intersect each other in a special place. Okay, what do? Give me a good geometry word. It's a kind of short word, not a real long word. Say it. Bisect. That's right. They bisect each other, which means they split each other how? In half, into two equal parts, right? So we'll call this E right here. So what might be true about AE and CE? They're equal to each other, right? And then what about DE and BE? They're equal to each other. Now, I put one tick mark here. That doesn't mean that this side and this side are equal. This is in red, that's in yellow. Okay, I just didn't want to put 3 marks and 4 marks. It gets a little ugly if I do all that. So what's true about the diagonals of a parallelogram? They bisect each other. So if I told you AE was 5 and I asked you to find EC, what would EC be equal to? It would be 5 as well, wouldn't it? Okay, what would AC be equal to? Howie? What would AC be equal to? It would be 10, right? Because if this is 5, that's 5, the whole thing would be 10. Make sense? But you know what they're going to do, and you've already done some of these problems on the worksheet and in the book. Don't they do stuff like this? They say this is like 3x plus 2, and this is 5x minus 1 or something like that, don't they? And then you have to solve for x, figure out the lengths sometimes and all that. So what would you do? What would you do with 3x plus 2 and 5x minus 1? Set them equal to each other, right? And you've been doing that all year long, haven't you? Been taking things and setting them equal to each other, solving for x. All right? Yeah, we've been doing it all year long. So that shouldn't be anything that's real new to you, right? That should be old stuff. You're like, oh, I've done that a bunch of times before. And we're doing it again. We're just doing it with different stuff, right? Just different things. You just haven't talked about parallelograms before, but you still set things equal to each other and solve for x. We've been doing that the whole year. Make sense? I think we covered everything on parallelogram. Was there anything I left out? Let me take a peek. Talked about the diagonals. Yep. The only thing we didn't talk about was this. Let me just do this real quick. Let me just draw this thing right here. Look at that thing. What's that look like to you? Looks like a rectangle, doesn't it? Do you know it's a rectangle right now, though? No, you can't really see it's a rectangle. In fact, we haven't even mentioned rectangle yet, have we? Have we? No. We will in another lesson pretty soon, actually. We'll talk about a rectangle and we'll talk specifics. But a rectangle is actually a parallelogram. So this is actually a parallelogram right here. So if this thing is a parallelogram, that means both pairs of opposite sides are parallel. Okay? Now watch this. What if I told you that that was a right angle right there? I mean, you probably assumed it was already, but you can't make any assumptions, can you? But I did tell you this is a right angle. What must be true about, let's do this. Let's call this WXYZ. If I told you that was a 90-degree angle, can you say anything about the other angles in here? Well, you know that the opposite angles are what to each other? They're equal to each other. So Z must be what? 90 degrees. Would you agree? All right. What about W? What's the relationship between W and Z? They add up to 180, right? They're supplementary. So if this is 90, what's this have to be? It's got to be 90 because 180 minus 90 is 90, right? They're not equal to each other because the angles next to each other are always equal, are they? But they're supplementary. If that's 90, that's got to be 90. Now tell me something about why. that has to be 90 as well, doesn't it? Because it's opposite this, or it's supplementary to this, or it's supplementary to that, right? There's lots of reasons why that one's 90. So if I have a parallelogram with one right angle, tell me something about the other angles. They all have to be what? Right angles. And there's a theorem that says that, okay? Does that make sense? And you're right, it is a rectangle, but we'll talk about rectangles in another lesson, all right? We'll get more specific about a rectangle. But a rectangle is a parallelogram. Did you know that? So a rectangle is also a parallelogram. All right. So now let's go to the worksheet that I gave you to do, and let's do a couple problems. Do you see anything on that worksheet? Let's stick with that first page. What was that first page? Page, what was it? 73? Is that right? Okay. So let's look at page 73. Is there anything on there that bothers you a little bit that you might want to go over? Nothing at all? Let's just do one then. Just to make sure that you guys are following along. These really aren't that hard, okay? Actually, if you know the relationships between the angles and the sides and all that kind of thing, it's really not that tough. So let me put some diagonals in here. This is probably one of my favorite chapters out of the whole entire book, okay? Just because it's kind of easy to teach and it's easy to learn, all right? And I'm like you. I like things that are a little easier, you know? No different. I slanted this right, didn't I? Well, actually I didn't for the one I'm not going to do. But that's okay. It doesn't make any difference. So let's say that this is 26. And this is y plus 1. I'm doing number 3. This is 19 and x minus 2. So that's 19 and that's x minus 2. Look, this couldn't be much easier, could it? If you know your algebra, basic algebra 1, you should be have no problem with this. Now, it tells you that this thing is a parallelogram. All right, it tells you. So you have to know it's a parallelogram before you can say this stuff is true. So if this is a parallelogram and I got diagonals, what's true about the diagonals? What do they do? Give me good geometry vocab here. They bisect each other. Exactly right. They bisect each other. So if they bisect each other, they split each other in half, don't they? So that means that this and this are what? They're equal to each other. So what do? You come down here and you set them equal. All right? It's pretty simple, isn't it? You just do that in your head. Right. Minus 1 from both sides, and y is 25. Easy. I'm not just saying that, am I? Just because I'm the teacher? I've been blamed. I've been accused of that many, many times. Well, you're the teacher, Mr. Hamrick. You always say it's easy. But in this case, I'm not lying, am I? That's pretty easy. What about this part? What about this right here and this right here? What's the relationship between them? They're equal to each other. So you go x minus 2 equals 19. Okay, you add a 2 to both sides. And x is 21. There you go. 21 and 25. Simple. We good? There's got to be stuff harder than that, is there? Let's do number 5. Five's, I mean, I wouldn't say it's hard, but it's, what am I doing? Let's try, I'm just trying to make this kind of look like the one in the book. There we go. That's pretty close. Probably comes down like that. All right, this is number 5 from that worksheet. Page 73, I guess. So this angle at the top is x plus 8. This one is y plus 9. And this one down here is 3x. And we have to solve for x and y. All right, so let's take a look. Well, what do we know? We know it's a parallelogram, right? All right, so what do we know about angles in a parallelogram? We know the opposite angles are equal. But do we want to set these equal to each other? So everybody look up here. I got a few people. Josh, Daniel, Summer. Let's go. Josh, somebody tap in, please. Let's take a look at this. These two angles right here, they are equal to each other. But is that really what I want to do? Do I want to set them equal? Do you see the problem if I set them equal? Look, if I set them equal to each other, can I really solve for x or could I really solve for y? No, because I got two different variables here, don't I? All right, so that's not a good option. Even though it's true. It's very true that they are equal to each other. Lonnie, what do you see? Okay, well, you would add them up, right? Yeah. Yeah, I know what you're saying, but when you say set them equal to 180, it's not really saying what you want to do. But I understand what you're saying. You add them up and you set them equal to 180. So let's do that. So I've got x plus 8, that's that one angle, plus 3x, and that's equal to 180. Because remember, the angles that are next to each other, we call these consecutive angles because they're right next to each other. The consecutive angles of a parallelogram are supplementary. I mean, it's a mouthful, but you understand what I'm saying, don't you? The angles that are next to each other add up to be 180. That's really what it's saying. And that's what we do. So let's do the math on here. X plus 3x is 4x plus 8 equals 180. And then we just go through the math and we solve for x, don't we? So we subtract 8, we subtract 8. That's 4x equals, what's that, 172? Is that right? Divide by 4. I don't know what that is. Let's do that right here. So it's 172 divided by 4, and that's 43. There you go. Oops, daisy. So x is 43. Now, how does that help us find y? Right there. Yeah, I could plug it in for this, can't I? Or I could plug it in here, but I kind of like this better because they're equal to each other, right? I don't know. Would you rather do that? So, yeah, I think so. So it's whatever 3 times 43 is. What's that? I should be able to do that in my head, but I'm going to do it here anyway. So it's 129. Okay, 43 times 3. So this angle right here is what? It's 129 degrees. That's right. So we set y plus 9 equal to 129. And then subtract 9. You can do that in your head, can't you? Subtract 9 from both sides, and that's 120. And there you go. There's your x and your y. It's not hard at all, is it? Don't you see that every chapter we do, the math is almost all the same? Would you agree? I mean, look what we're doing. We're still adding stuff up, setting equal to 180. We're still setting things equal to each other. Haven't we been doing that the whole year? I don't know if you remember, but back early on, I said, I really don't think these chapters get harder and harder. I think you're doing the same exact thing that you did at the beginning of the year, but you're just doing it with different stuff, with different pictures. Do you remember me saying anything like that before? Okay, I did. Look it up. All right, so would you agree with that statement or not? Do you think the chapters are really getting progressively more difficult? I don't think so. I think I think the difficulty level has already peaked, right? I think it's gotten as hard as it's going to get. It's just we're doing the same thing over and over again. We're just doing it with different pictures, right? And different figures. That's the nice thing about geometry is once you get a hold of it and once you start getting the hang of it, it really doesn't get harder and harder. I don't think it does. It just gets different. That's all. There's a difference between being different and getting harder and harder. I really think that that's true if you really look back on it. Okay? I don't know if that encourages you, makes that easier for you or not, but it's just something I thought. Is there anything else? What about on the book? Were the problems in the book any more difficult than the problems in the worksheet? They look pretty much the same, don't they? 19, which one? In the book? Okay. All right, let's do 19. Picture kind of looks the same, so it's going to copy and paste the same parallelogram. It's a little bit more stretched out like that, but it's okay. And they say this angle up top is 2y. It's weird looking too. And then x minus 5 is this angle. This one down here is 2x plus 11. So everybody seems good on this. So you ready for a quiz on this tomorrow? Yeah, I think you should be. All right, let's take a look. Well, first of all, the opposite is pretty much the same thing, isn't it? So let's just do it real quick. The opposite angles, do I want to set them equal to each other? No. Are they equal to each other? Yes, they are. But I don't want to set them equal to each other because this has a y and this has an x, and I'm stuck. I can't do anything if I do that. So I look for some other ones. What about these? Do I set those two equal to 180? Again, no, because I got an x and a y. So what am I looking for? I'm looking for to do something with the same letters, aren't I? So where do we have the same letters? This one here and this one right here. Everybody see that? They're next to each other. They're next to each other in a parallelogram. They're considered consecutive angles. So what's true about these two angles? They add up to 180, right? Don't set them equal to each other. I mean, you can just look at them until they're not equal. What kind of angle is this angle up top here? It's obtuse, isn't it? And what kind of angle is this down here? It's acute. Is there any way that they're going to be equal to each other? Not at all. All right? So they do add up to 180. So let's do that. So it's x minus 5 plus 2x plus 11, and that equals 180. Pretty much the same problem we just did. Let's do this. X plus 2x is 3x. Negative 5 plus 11 is plus 6. That was one little extra thing that we didn't do on the other problem. And now it's all pretty much the same. Subtract 6 from both sides. So that's 3x equals 174. Didn't we use this number already? Did we? Okay. Does that come out even? 174. 174 divided by 3. And that's 58, so x is 58. All right, so we're good there. So what are we going to do here? We want to find y, right? But let's put it in here. That's probably the easiest. You could put it in here, I guess. But if x is 58, what's this angle? What's this whole angle? If x is 58, what's this angle right here? It's 58 minus 5, isn't it? Which is 53 degrees. What's true about this angle and this angle? They're supplementary again, aren't they? Now, you could have plugged in x for this, but that'd be a little bit more difficult, right? I don't know. It doesn't matter. You could have. I'm just going a different way because we did it this way earlier. So if this is 53, what do? I go 2y plus 53 equals 180. Subtract 53 from both sides. So that's 2y equals, what's that, 127? Is that right? Did I do the math right? I think so. 127 divided by 2. That's not going to come out even, is it? 127 divided by 2. Yep, 63.5, and I think that's what I said, isn't it, when I read off that answer. So y is 63.5. Yeah, I don't think there's anything really that difficult with this, do you? No, I don't think so. All right, well, that's about it, isn't it? No, you don't have to draw the picture. Okay, but look at the work, though. All right, so when I say show your work, which I wrote quite a few times on that last lesson I turned back, okay, look, that's the stuff you need to do. You can't just do that in your head. I can't do it in my head. So I figure if I can't do it in my head, very few of you will be able to do it in your head. Okay, write the stuff down. Even if you could do all that calculation in your head, I still want to see it on your paper. You get it? All right, and I've harped on that all year long, haven't I, about showing your work? Yes. All right, so it shouldn't be a surprise to you. And look, all that stuff right there. So all that stuff to solve for x, all that stuff to solve for y, that's the kind of stuff I want to see on your paper. If you don't have enough room on those worksheets that I give you, do it on a separate sheet of paper. But if you do your work on a separate sheet of paper, you need to turn it in, right? And I need to see it because that's what I'm looking for. I'm not looking for right answers for this. I've already given you the answers. It was up to you to decide if your answers were right or not. Okay, what am I looking for? I'm just looking for your work. I'm looking to see if you gave it an honest effort. Everybody got that? That's what I'm looking for. You've already checked to see if your answers are right or not. I'm just looking to see if you actually put the work into it and didn't just write down the answers as I read them off to you in class, which several people still try to do and try to get away with it. All right, but you're not getting away with it. All right, you're getting many points off, and if I get really tired of seeing that, I just might not give you any points whatsoever for your homework if you just write down the answers and turn it in. All right, so I'm collecting two things today. I'm collecting the worksheet and I'm collecting the stuff from the book. All right, so turn them both in. People in the front rows, if you could separate them, one pile worksheet, one pile with the stuff from the book, and that's it. That's all we're going to do today.